So these are the solutions for the H3 reflections. Hopefully you watched the video to learn about the conditions. And one of the questions is, which of the following conditions do not need to be met when a normal distribution, when using a normal distribution for the sampling distribution for proportion? So I'm actually going to go to the notes packet and look at the conditions for sampling proportion. So there are a couple that come up. One is the 10% condition. So we want to make sure that our sample is less than 10% of the population size. The other one is a large counts condition, and you actually had a preview of this last class when we worked on the activities, and that is we want to have at least 10 successes and 10 failures. And then I think the other condition we run into is we like to have a random sample to make sure that we don't have any biases. So expected number of failures must be at least 10. That is a condition, so that is not the answer. We need to make sure the sample is less than 10% and successes. So this one right here, having at least 30 samples, that really has more to do with the very beginning of the packet when we're talking about sample means. And it should have been the central limit theorem if I brought it up. Yeah, there it is. That's about means. That's not about proportions. Okay, I'll go back to my notes for this unit, for this section, which is H3. So the one that is not a condition for proportions is this one. The sample should have at least 30 samples. All right, which of the following is a true statement? The sampling distribution of p hat has a mean equal to the proportion p. The sampling distribution of p hat has a standard deviation, so that is true. All right. The sampling distribution of p hat has a standard deviation equal to square root of n times p times 1 minus p. That's not true. The correct formula is, if you look at it right there, that is the formula for the standard deviation. So they had the n on top, the n goes on bottom for the proportions. So not true. The sampling distribution has a standard deviation that becomes larger as the sample size becomes larger. That's true for binomial distributions, but it's not really true for proportional distributions. You can see how it gets thinner with larger sample size. I don't think I have any really good examples here. I do have my AP lesson. Here we go. So here we can look at different sample sizes, and you can see that it becomes tighter. Okay, and the sampling distribution of p hat is always close to normal. No, not necessarily. If you look at some of these here, we've got some skewed distribution, so these won't work. They'll work if you get big enough samples, but not always. So the correct answer on this one is the sampling distribution of p hat has a mean equal to the proportion p. Solomon is taking randomly selected samples to estimate the percentage of students who vape. The population he is estimating has 400 students. The proportion of students who vape is 40. He is taking samples of size 50. Why should he not use the normal distribution? So if I go to my scratch work here, I'm going to paste this problem in. So we're going to check the conditions. So really, the good news is he's taking a random sample, although you guys don't spend as much time on that part as my AP does. They really have to check that. So first of all, let's check successes, right? Successes equals n times p. So we have a sample size of 50, that's n, and p is 0.4. When you multiply those out, you'll get 20. Expected failures would be n times 1 minus p, or just the balance of the sample. Pretend that's a p. So it's going to be 50 times 0.6, which is 30, and you can see 20 and 30 adds up to the sample. So just to be clear, hopefully you notice that this piece right here, that's n. Okay, that's n, your sample size. Okay, and this is p right there, the proportion of students that vape. All right. The next condition we want to make sure of is that, so both these conditions are at least 10. So this is good, at least 10. So this is met. This one's at least 10. So this condition is met. So we have one condition left besides random, and you can see random, Solomon is taking random samples. So this is met. So there's one condition left, 10% condition. 10% means the sample has to be less than 10%. 50 is more than 10% of 400. So this condition is not met. All right. So basically the condition that's not met is the 10% condition. There you go. Okay. So I will go ahead and click that on the next one. In a school of 2,500 students, the students in a stats class are planning a random survey of 100 students to estimate the proportion who would rather drop lacrosse rather than band during this time of severe budget cuts. The teacher suggests instead to survey 200 students. So why does he do that? Does he want to reduce variability, bias, increase variability, increase bias, or make possible stratification between lacrosse and band? So first of all, we don't want to increase variability or bias. That would be bad things. Bias has to do with using randomization. Variability is the one that has to do with your sample size. And if you look at your notes near the beginning, see how we are reducing our variability right here. Okay, so that would be reduced variability. I'll go ahead and submit these. And yay, they're all right, as they should be. And now we'll go to the last part. So now we have a normal distribution with mean of 42 and a standard deviation of 36. All right, so you will not be using the normal, so don't worry about normal approximation. I stopped dealing with that. I can actually edit that out now. So our first question is, let me go ahead and type the problem in. So here's the problem. So don't worry about this part, okay? So we have a normal distribution with a mean of 42 and a standard deviation of 36. Okay, they want to know what is the mean for the sampling distribution. The mean should stay the same. So if the mean was 42, it stays 42. What's the standard deviation? Well, we're doing a sample size of 36. So if you look at our notes, here is the formula. So that's the formula we want to take right there. Okay, this formula right here, that's what we're using. And so let me go ahead, there we go. So there's the formula. So mean stays the same. Mean stays the same, still 42. SD is going to go down, your standard deviation, all right? SD decreases because of larger sample size. So we're going to use the formula SD equals, which is basically this one right here. We're going to do the square root of, I'm sorry, oops, I have the wrong formula. Okay, oh, glad I caught this. I'm doing a proportion here. This is not a proportion. Throw that one away. So this is actually going back to our older unit, our first lesson, H1. So I need to go back to H1 because this is proportion. I had a mean. I don't have a proportion here. So we're going to go to the very beginning. And I have a formula. Aha, look at that. There it is right there. I just happened to come to the right page. So it should be around page 2, the first page of your notes from the last unit. This little puppy right here is what we want. So let me paste that in. There's the formula I want. So I just take my old standard deviation divided by my new standard deviation. So my old standard deviation is 6, and I divide by the square root of my sample size. My sample size is 36. So let me put a 36 in there. And I don't know if you know this, but the square root of 36 is 6. So my answer is 1. Oops, not minus 1, equals 1. Okay, so the answer is 1 right there. What is the probability that an individual in a sample is greater than 43.5. So this one, what we got to do is use the correct normal model. All right. So I'm going to paste this in here. This is the next problem we're doing. There we go. So what's the probability an individual in the sample? Excuse me. I just realized something. I'm going to have to shift. You're going to see some of the magic. Or not. See the people behind the curtain. There we go. Problem was I couldn't bring up my page. So what we're going to do is we're going to use a normal model of a mean of 6, right? Because we said the original mean, mean of 42. And the original SD of 6, okay? Because that's for individuals, all right? So if I go to my Staplet, do a normal distribution, and I want to be greater than 43.5, so normal distribution, make it mean of 42, standard deviation of 6. We are calculating an area, okay? We are calculating an area right there. And we want it to be greater than 43.5. So to the right of 43.5, calculate your area, and I'll do my labels on my plot. And you can see that the area is 0.4013, or about 40%. You can see it's close to half, but not quite. So this is the answer. Boom. All right. So that, let me go ahead and click it on my answer. So about 0.4013. There you go, right there. Now it's saying, what is the probability that the sample mean for a sample of size 36 is greater than 43.5? So let's go ahead and we'll paste that in as a problem. So this is the last part. Oh, I thought I copied it. Control-C. Wonder if you're learning shortcuts listening to me speak them out. So now this one is different. This is going to use a different model. The model's going to be the mean is still 42. All right, because means don't change with increasing sample size. They should stay the same. But remember, we calculated in this problem above a new standard deviation of 1. So now I have to go back, and is it the same number, 43.5? So it's pretty much the same question, but I have to change this to 1. And now you can see that I get a much smaller number. Instead of almost half, it's closer to 5%. So because what happens is the standard deviation tightens up, and you can kind of see it here when I paste this picture in. See how it was going from 24 to 60? Now it's only 39 to 45. And our answer is 0.0668. That's pretty much that. We hit submit answer. And all are correct. So share with me here any questions you still have after watching the solutions, or anything that you thought you learned. Always helpful to hear from you.